This will be a basic walkthrough of some Python commands that you can use to do root finding. If you just want to jump straight to the root finding algorithm, check out the next video. So I would recommend that you type these along with me and pause to make sure that you can run each exercise correctly. I went to repl/it/languages/python3. You're going to type your program in here, and then when you click run, the results will get displayed there. So the first thing is the print command. You can use print to display things. So this is the simplest program you can write. Print hello. And I click run, and you see over here it displays hello. Whatever you have between the double quotes is going to get displayed. So I can type hello there, and it'll display hello there. Okay, let's talk about variables. So you can create numerical variables like this, a equals 4, and that's going to take 4 and save it inside a. And then if I wanted to, I could say hello there, a is, and then I have a comma, and I can print the value of a. So when I run this, I'll say hello there, a is 4, because it's printed literally what is inside the text inside these quotes, and then the comma means I'm going to print something else. And then a, it will display the value that's saved inside the variable a. Let's do a couple calculations with a. So if I want to add 1, you might think that you could do this, but this doesn't actually tell the computer that you want to save the result back inside the variable a. So you need to do this, a equals a plus 1. Mathematically, this doesn't really make sense, because in math class, this would be saying there's some number that's equal to itself plus 1, and there are no such numbers. But in programming, you're saying evaluate what number the right-hand side is equal to, and then save that inside the variable on the left. So here, we ignore the left-hand part, and we just say, what is a right now? It's 4. We add 1, that's 5, and we save 5 back in a. So now if you want to, you can copy and paste this. So now when I run it, it'll say, hello there, a is 4, and then we'll add 1, and it'll say, now a is 5. Let's do a couple of other operations. So I could say 3a plus 1, and you can run it, and that should say 13. If you wanted to, you could say 3, well, let's do this one. So if I wanted to say 3a squared, you might think you'd do this, because that's often how we write it down when we're typing. But that actually doesn't, that's not the exponent 2. In Python, you would use star 2 to mean a to the power of 2. So if you run that, here, let's take away the 3. So this should be a squared plus 1 is giving us 17, because this is 16, and I add 1. If you wanted to, you could reverse these to make an exponential equation. 2 star a would mean raise 2 to the power of a and add 1. I run that, and now we get 17. Oh, that makes sense, because 2 times 2 times 2 times 2 is 16. Okay, enough of that. Let's talk about looping. So if you want to, you can delete all of these. Let's type 4x in range 1, 10, and then a colon, and then enter, and then print x, and type enter. So if we run this, you'll see that it displays 1 to 9. What's happening is all the lines of code that come after this colon that are indented, see how this has a couple of spaces? All of those lines are getting repeated over and over and over again for different values of x. So we're saying x is going to be a variable, and we're going to assign x different numbers in this range, starting from 1 and going up to 10, but we're not actually going to include 10. So the first time we go through line 3, x is going to be 1, and we print 1. And then the next time we go through, it's going to be the next number in the range, 2, and we print 2. So experiment around with this a little bit to see what you can do. So this is going to go from 3 up to 99. You can run it and see that it does. Here's 99, and then if we scroll up, you see 3. You can also go into negative numbers. So let's start at negative 10 and go up to 10. Did I press run? No, I guess not. Oh, okay, so here's something else to know about. it looks like it didn't work, but actually the output is continuing to add down at the bottom here. So here's my negative 10 to 10. If you want to clear your output, you can hit this button to clear it. Let me run it one more time. And there's negative 10 to 9. If you don't want to go up by 1, if you want to go out by something else, you can have a third number here. This is called the step size. So we're starting at negative 10, we're going up to 10, and we're going to go up by 2's. So if you run it, you'll see now we're only going up by even numbers. Or if you wanted to, you can do 3's. If you want to count backwards, you can do this. Start at 10, go down to negative 10, but the step size is going to be negative 1 because we want to subtract 1. Starting at 10, we want to subtract 1 each time to get to negative 10. So now 10 down to negative 9. So here's a little exercise that you could use to test your understanding. I want you to display a data table for all the values of x squared plus 1, if that was a function, starting at negative 10 and going up to positive 10. So if you want to pause it and try to get as far as you can do that. Otherwise, I'm going to show you the answer right now. So I'll say 4x in range, going from negative 10 to positive 10. First, I'm going to calculate the result. So I'll call that one y. I'll say y equals x star star 2 for x squared. Or if you wanted to, you could just say x times x. That's the same. Plus 1. And now I'm going to print x. And then maybe I'll print a little arrow, and then y. And if I run that, that gives me a data table showing what x squared plus 1 is in that whole range. Go ahead and give this a try by changing this to be a different function. If you want to, you can actually define your own functions instead of typing the mathematical expression you want. Let me show you how to do that. So you have to define your function before you use it in Python. So up here, let's say def, which means that we're going to define a new function. We'll call it f of x, and you have a colon, and everything that happens after the colon, that's going to be your function. The word return means that whatever comes afterwards is going to be the output from your function. So let's do x times x plus 1. So right now we've said anything, so now you can use f like an actual function. I can say, here, let's call this val, okay? So val is going to go from negative 10 to 10. I'm going to say, tell me what the f function of the input val is. So what that's going to do is, first time through this loop, when val equals negative 10, we're going to ask what is the f function of negative 10. And that negative 10 is going to get evaluated up here, so we'll do negative 10 times negative 10 plus 1. And then that gets returned as the output from the function, and now we'll save that into y and display it. You might be wondering why this has some red underlining. If you hover over it, it says undefined name x. So before, this was x, but I decided to change it to val. So when I changed it to val, I want to change my print statement as well so that it's displaying val. So if I run this, it's going to give me the same output, but now my function is defined up here, and I can use actual function notation if I want. Let's do two more things. First, I'll show you how to get user input. So let's make a new variable called start, and I'll have input. And then this is what displays. So give me a starting value, and then end equals input. Give me ending value. And let's just print these to make sure we know what they are. Start to end. So I can run this. And now it says give me a starting value, and I'll type 8. Give me an ending value, I'll type 10. Maybe we want to fix it so that these numbers aren't jammed together like this. But now it says 8 to 10. Great, so I can see that whatever I typed in got saved inside the start variable, got saved inside the end variable, and now I can use them. So let's do this. I'm going to put a colon and a space so that the display looks a little bit nicer. I'm going to delete that print statement. But now instead of having my range start from negative 10 to positive 10, I'm going to start at this variable, whatever they typed in as start. And I'm going to go up to end, whatever they typed as end. So now we'll run it. Give me a starting value as negative 100. My ending value is going to be 5. Uh-oh. Okay, so this seems to have worked before because you could display the numbers. But actually, even if you're typing numbers, the computer thinks that you're typing text, because to the computer, this numeral 5 is a letter, just like A or B. So if we want the computer to be able to treat these as numbers, you have to tell the computer to treat it as a number like this. So you can say, oops. So there's a command that will let you convert something into an integer, and it's called int. So you can say int, and then open bracket. And then, well, actually, let's do it this way. So let's say start equals int start. And what that's doing is it's saying, take the text that they typed here, convert it into an integer, and now save that back into the start variable. End equals int end. So now that we've converted them into integers, let's run it again. So negative 100 and 8. And now we've started at negative 100 and gone all the way up to 7. Okay, the last thing I want to show you is called an if statement. It's a way that you can ask a question and do something different depending on the answer. So first, let's change our function so that it's maybe x squared minus 10, and we can display. Let's display it from negative 30 to 30. You see that mostly we have positive outputs, but then for some numbers we have negative outputs, and then we go back to positive again. So I want to have an if statement that will test if a number is positive or negative and display some words. So here in our print statement, let's do this. I'm going to say if y is bigger than 0. So I'm testing to see if the output if the output that we're going to display in the table is larger than 0. We'll have a colon. And you have a tab to tell the computer this is what you want to do if that test is true. So if y really was bigger than 0, then we print. If y isn't bigger than 0, or if it's equal to 0, or smaller, we don't do the print statement. So let's just run it the way that it is right now. Alright, so I'm going to start from negative 30 and go up to 30. And if you see, it's only displayed positive values. We skip straight from x equals negative 4 to x equals positive 4, because in between, that's where the negative values were. So let's do this. Now let's have another if statement. If the output is less than 0, let's do the same thing. Print val, comma, and some arrows, and then y. So this is actually going to print the same thing no matter what. But let's add a last thing. Is positive and is negative. So now, depending on whether the output's positive or negative, our program will tell us that. Okay, so let's do negative 10 to positive 10. And so we see is positive, and then is negative, and then is positive. All right, so come back in the next video and you can see how to put all these pieces together for a root finding algorithm.